Okay, so here's the setup for this problem. We have some owl that's flying, and it's 4 meters, 4 horizontal meters, and 12 vertical meters from a nest. And it drops a mouse. It's trying to bring, this owl's trying to return to its nest, feed its young. And this mouse falls out of the owl's talons. And at the moment the mouse is released from the talons, the owl is traveling in a downward direction, 30 degrees below horizontal, with a speed of 3.5 meters per second. And the question we're trying to ask is, does the mouse actually land in the nest? So this mouse is going to take some trajectory then. And the question then is, does it actually make it in the nest or not? Okay? So we're told the size of the nest. And really this is just a projectile problem. It's sort of disguised with kind of some confusing language. But basically what we're asked to find here is this mouse. Basically this is the same as just having the mouse traveling initially downward at a 30-degree angle with a speed of 3.5 meters per second. And we want to know, where does the mouse land? Okay? So that's basically what we want to calculate first. We want to figure out, where does the mouse actually end up once it's fallen a distance of 12 meters. Okay? So where does the mouse land after falling a distance of 12 meters? Okay, so the first thing, remember, in any projectile problem is to calculate how long is the projectile in the air. Okay? So we want to know how long the mouse is in the air after falling 12 meters. Okay? So here's the initial y height of the mouse. Here's the final y height. Okay? And we want to figure out how long is it in the air. So remember, the first step in any projectile problem, well, besides calculating the time, is we want to know what the x and y components of that velocity are. Okay? So the x component of the mouse is, remember, it's the velocity times the cosine. Okay? So when you're dealing with the x component here, we want to know what this length is here of this vector. Okay, to figure that out, we need to take the cosine of 30 and multiply it by 3.5. So that would be 3.5 times the cosine of 30. Okay? So you do that calculation, and you get 3.031 meters per second. Okay? Now, same for the y component. The initial y component is going to be 3.5 times the sine of 30, but we have to take into account that it's downward. Okay? So downward is a negative velocity. So this is our y component here, and that's in a downward direction. Okay, so it's going to be negative 3.5 times the sine of 30. Okay? So you do that calculation, you get an answer that is negative 1.75 meters per second. Okay?